Welcome you all. Today we are going to discuss a topic called Kruskal algorithm from the subject of design and analysis of algorithm. So let's move on to the topic. So Kruskal algorithm is used for constructing a minimum spanning tree. What is this minimum spanning tree? We are going tree means we will having a set of edges and vertices. We are going to visit all the vertices without forming the cycle. So that is in a minimum cost. So that is said to be a minimum spanning tree. Spanning tree means traverse throughout all the nodes, minimum spanning tree in minimum cost. That is what minimum spanning tree. So they have given the input as weighted graph v comma e, so it's set of vertices and edges, and output is a set of edges composing the spanning tree of G, which is in non-decreasing order. So they have initialized something. E3 is 0 and encounter is 0 and k is 0. So when I encounter with vertices minus 1, I am getting inside. So when I am not have visited all the vertices, still visiting all the vertices, that is the condition, I have to place where I have to stop. So I am incrementing the k value. I found it if it is acyclic, if any of the vertices, if I am including with a minimum cost, if it is found to be acyclic, that is it is not forming a cycle, I can include it in my tree. So that is what they have depicted over here. I am repeating the procedure again and again. So move on to an example. So they have given a set of 6 nodes weighted graph. So now this weighted graph has been written. I am going to write the edges in a non-decreasing order or ascending order. So the minimum edges BC. So BC is 1 and EF is 2. So I am writing all the edges in the non-decreasing order. So once I write in a non-decreasing order, first I have to choose the smallest edge. Okay, and I am going to see whether including this particular edge is going to form a cycle or not. If not forming cycle, I can accept it. So B and C. B and C, I found it both B and C is not visited. Okay, so I can say it as B and C, it is not visited. So I'm going to include this. See here I have included this. So it is not visited. So that's why I have represented in a bold format. And so now B and C are the known edges. So initially I didn't visit any of the vertices. Now I have visited B and C. So now I am inspecting the remaining edges. So this is out. Now I am going to inspect the remaining edges. I found that E and F is found to be having the smallest one. So I am going to include E and F. So where is E and F? This is my E and F. Okay. So including this particular edge is forming a cycle? No. Okay. So now I have visited 2 more new cities, that is F and E. So E and F is my new vertices that has been added. Okay. So now I am seeing remaining edges which has been written already in the sorted order. So I found A and B as the next smallest edge. So this is already known and this is also already known, and I am finding A and B. Do this form a cycle? No. Where B is already has been visited. Now A is the new one that has been visited. So I am including that. Next I am moving on the further new edges BF. Here I have 2 edges with 4 value BF and CF. So B already been visited. Here C already been visited and F is not visited. I can choose any of the edges of your choice, but it should not form a cycle. So I am just seeing BF. Where is B? Let this be. So BF, CF. I can take any of your choice. Both is not going to form a cycle. Yes. So I am just taking BF. Okay. So now BF has been included. So next I am moving on to CF. CF is 4, but if I include that, here it is forming a cycle. So I am just neglecting that. So moving on to AF. So AF I am considering. Again AF if I take, it is also going to form a cycle. So neglecting that, then I am moving on to DF. So DF, where is D? Okay, DF. So I am accepting that. This procedure or choosing an edges has to be repeated again and again until I visit all the vertices. So again this has been accepted. Now I finding that A, E, C, D, D, E. So A has been visited, E is also visited. When I am choosing an edge, any one of the nodes should be unvisited so that it can be included. If I am going to CD, again C and D both visited, D and E both visited. So finally done. So I have BC, AB, BF and FD and E. So this is my node. So B, here I have B, here I have C, here I have A, here I have F, here I have D and E. So now all of my nodes has been visited. What is the cost? Here I have 1, I have 3, 1 plus 3 is 4, here I have 4 again, so 4 plus 4 is 8, here I have 5, 8 plus 5 is 13 and here I have 2. So the total minimum cost is 15. So 5 plus 2 7, 7 plus 4 11, 11 plus 4 15. So the minimum cost 3 constructing an Kruskal algorithm is 15. Hope you understand. Thank you.